Okay, so trigonometry of right triangles. Most of this lesson will be review, but some of it might be new, like reciprocal functions you might not know about. So we are talking about right triangles. So typically, at least right triangle trig, you're talking about right triangles. So I'm going to draw kind of a basic right triangle here. And so we're going to call this angle, we might even call it a Greek letter, theta here. This is a right triangle, so it has a 90-degree angle. And so this is the formula here. Just for sake of having numbers, let's just plug in some numbers here. So this would be 3, let's just call 3, 4, and 5. That's a really famous right triangle. 9, a squared plus b squared equals c squared. 9 plus 16 is 25. Okay, so let's set up your 3 trig ratios you know and love. So sine of theta is equal to the ratio of, if you think about the memory trick you might know, so toa, this is just a word we in math use to memorize this. So this means the opposite over hypotenuse, which in this case, the angle opposite, the side opposite angle theta is 3. And the hypotenuse would be 5. Then we'll set up the cosine of theta. And cosine is adjacent over hypotenuse. That's what that helps with, adjacent over hypotenuse, which in this case is the adjacent side, the one next to it, but not the hypotenuse, is 4 over 5. That's the ratio. So sine, cosine, and tangent are ratios of numbers. So sine of theta is 3 over 5. Cosine of theta is 4 over 5 in this case. Tangent is the next one. And that, of course, relates to the OA there, which is opposite over adjacent. In this case, the opposite side is 3, opposite to the angle. And then the adjacent side is 4, the one next to it, but not the hypotenuse. So the tangent theta is the ratio of 3 to 4. If you just told that, the ratio of the sides is 3 to 4. It might be 6 and 8, might be 9 and 12, but the ratio is a 3 to 4 ratio. Now let's talk about the reciprocals of each one of these. So these are the reciprocal trig ratios. So there are 3 reciprocal trig ratios. And so I'm going to write them in order that they are. So they are the reciprocal of sine. So these are the reciprocal ones. Are going to be, this is going to be cosecant. So CSC, cosecant of theta, which is reciprocal means you flip it. So it'd be H over O, or in this case, that would be 5 over 3. The reciprocal of cosine is secant. So secant of theta, if you were a SEC football fan, that makes sense. The reciprocal of that is H over A. So this would be 5 over, adjacent side is 4, so 5 over 4, or just flip that 4 over 5 there. And the reciprocal tangent is probably the easiest to remember. This is called the cotangent. So the cotangent of theta, instead of O over A, it would be A over O. In this case, A over O would be 4, 5, no, sorry. A is 4, so 4 over 3, which is reciprocal of 3/4 there, which is the tangent. Okay, those are the 3 reciprocal functions. Those are ones I need you to memorize. I don't know if this helps, but sometimes I think of like C and S kind of go together. They start with the same, like C and S kind of go together there. So that the reciprocals start with C and S alternately, because everyone knows sine, cosine, tangent. But the reciprocals, sometimes these two get confused as to which one they go to. So I remember one starts with S, the other starts with C when I do this. Tangent, I just know it's cotangent. Like that's just kind of a given that tangent and cotangent go together. But the other two are kind of hard to remember. So I remember C and S go together. You have to remember that somehow. Again, they're just reciprocals. This is different than the inverse functions. We'll talk about inverse functions in a minute. We're not there yet. We will actually talk about how these are used as well. Let's look at an example. Oh, I use the same example. Let's convert this. Let's write a slightly different example here, just so we have something else. So let's make this one our second favorite triangle. So let's make this 13 and make this side 5. Okay, set up the trig ratio. So by the way, we are missing a side there. So So I would recommend plugging in the Pythagorean theorem. So a squared plus b squared equals c squared. So 5 squared plus b squared equals 13 squared. So 25 plus b squared equals 169. Subtract 25, so b squared equals so 144. So square root both sides. Don't worry about plus or minus in this setting because this length of a side is going to be positive. We don't really want negative 12 for the length of that side in this setting. So we're going to say 12. Okay, so we're going to set up the trig ratios and we're going to solve this for theta. Oh, this just says solve for theta. We actually didn't need that side, did we? We can set up the trig ratio just given two sides and find the angle. So let's just solve that. Okay, so sorry, there's a little too much work, but it's nice to know you can do it. So this is going to be sine of theta because I have the opposite and hypotenuse there. So sine of theta equals 5 divided by 13. And the last step, this might make sense if you, do you remember this kind of theorem? This is kind of going back to something we learned in our previous chapter. The inverse, f times the inverse of f of x is equal to x. When you compose a function with its inverse, you actually just get the original, whatever you plugged in. And so the way to get this on the other side, this is kind of a weird step, but I'm going to take the inverse sine of both sides. So the inverse sine of both sides. I'm showing you why this steps work. This is a step you've actually used before, probably many times. So sine of theta was on the left side and 5 over 13 was on the right. So this is the part I want you to see. This is like this. When you compose a function with its inverse, you're left with whatever you started with. So when you compose inverse sine with sine, you're just left with theta on the left-hand side. You can't divide by sin, you can't divide by sine, you can't divide sin out of your life. It's a deep truth there. So you have to compose the inverse function. We don't always show this step. I don't think anyone I know really shows that step. They just go right to this step. They would then type that in your calculator. It's really kind of a calculator step that you do. Just want to see why it works because now we understand things a little better. So you want to type in inverse sine. So if you go to the trig key in your calculator, inverse sine is right below regular sine. So inverse sine of 5/13. And let's see if I get it. I want to kind of pay attention, make sure you answer when you hit a decimal there, control enter. That doesn't make sense. It says the angle is 0.39 degrees. And if you're paying attention, do you see this little RAD in the quarter? So that means radian. If you click that, oh, now it says DEG for degree. Let me copy and paste that same command. Oh, got to hit control enter. Oh, that answer actually makes sense. So theta is 22.6199. By the way, general rule of thumb this chapter, I just want you to get in the habit, this chapter only, not every chapter, of going out 4 decimal places. There's a reason for that, especially when you get to law of sines, law of cosines, go ahead and go out more than we're used to. It'll make a difference in a positive way here. And that answer makes sense. It looks like maybe a 22-degree angle. So we were in the right mode there. That's good. Find x. By the way, I don't know if you know this. This is actually the best math jokes. Find x. Some student just goes like this. I found it. It's right there. Maybe I should have said that better, but it's a good math joke. But really it's saying find the value of x, right? So we're going to find the value of x. So you've got this angle there, you've got that. So let's set up the trig ratio. So this, hopefully you're going to choose tangent here because I have opposite and adjacent. So tangent of 40 equals the ratio of 5 divided by x. You're going to solve that, you're going to multiply both sides by x. That cancels really nicely. You get x times tangent of 40 equals 5. To solve for x, one more step, divide by tangent of 40. Divide by tangent of 40. You're going to type that in your calculator, and you get x equals 5 divided by tangent of 40. And again, you want to hit Control Enter. So you get x is approximately equal to, let's see if this makes sense, 5.9588. I round it off to 4 decimal places. And does the answer make sense in the context? It looks a little longer than 5, so it's 5.95. Okay, I think that's reasonable. I'm not sure if it's exactly a 40-degree angle, but that seems like a reasonable answer, so I'm pretty happy with that. You might be wondering why we even learn about reciprocal functions, like what's their purpose? It's really just to show off. So if you use the reciprocal function here, the reciprocal tangent is cotangent, so this would be cotangent of 40 equals, instead of x over 5, I mean 5 over x, it'd be x over 5. Takes one step to solve, so on both sides, you're just going to multiply both sides by 5, multiply by 5. And the nice part is, you get x equals, like we solved this in one less step, so then you type in that in your calculator, which is actually not as hard as you think. 5, trig key, cotangent is there, cotangent of 40, I'm going to put a decimal point so it gives me a decimal, and you get the same answer in one less step. So why did we learn about reciprocal functions? Because it could save us a step. If you're thinking ahead, you can go, I could just use a reciprocal function here, and that would save you a step. Woohoo! Very exciting. Okay, so let's try this one. Let's see, you got to figure out if it's sine, cosine, or tangent. SOHCAHTOA. So I have the adjacent side here. Sorry, I have the hypotenuse here. So this is definitely going to be cosine. So cosine of theta equals 5 over 13. This is really a calculator step you do next, so it's going to be the inverse cosine of 5/13. Essentially, I took the inverse cosine of both sides. So that'd be inverse cosine trig, inverse cosine of 5/13. Control Enter. So theta is approximately equal to 67.3801. But that makes sense in the context. It looks like it could be a 67-degree angle if it's roughly drawn to scale. I think that's correct. Last two, again, I hope these are something you've seen before. So if you take a square and cut it in half, so it's a hypotenuse there. It's a really beautiful drawing there. Okay. Right triangle. Square, what I mean by that is those sides are equal. Then what would happen is it forms what's called a special triangle. This one has a 45-degree angle here and a 45-degree angle there. So there are two. The first one I'm going to talk about is the 45, 45, 90. It's a catchy title, isn't it? 45, 45, 90 triangle. You've probably seen this one before. I think this is review. I think you've had this before. So if this side is x, this side is x. And the thing we just memorized is this is going to be x times the square root of 2. Hopefully you know that already. So if I asked an example problem, I said, okay, here's a special triangle. I may not announce it from the rooftops, but I say, okay, this is 10, this is 10. How long is that side if this is 45 right there? Well, you would say, okay, let's use the property. So this would be 10 root 2, and you're done. So fast, right? If they asked us in a backwards way, so they said, okay, here's another 45, 45, 90. Those sides are equal, so it must be 45, 45, 90. So this is 10. Ooh, go backwards. So how could you go backwards? Instead of multiplying this side, x, or whatever you want to call it, by square root of 2, you're dividing. You're going backwards. Instead of multiplying by square root of 2, you're going to divide. So this side would actually be 10 divided by square root of 2, which we don't really like that answer. We're going to rationalize it. We don't like radicals in the denominator. So this would be 10 root 2 over 2. And that actually does cancel. That makes 5. So this would be 5 root 2. Okay, there's one more type of special right triangle. Maybe you've seen it before. Looks roughly like this. And this side is, this angle is 60. This angle is 30. And this is called a really creative name, 30, 60, 90 right triangle. And so you're going to set up, so this is going to be, let's call this x. If this is x, it almost helps to think of this as like almost like an equilateral triangle there, like, whoops, sorry. So it almost works like an equilateral triangle there. So what I mean is that, if you had kind of like a triangle that made, kind of over there. So it's like half the triangle. So it helps me to remember that, because sometimes I think, okay, this is like half a side. So this side is always 2x. So if you remember that, like kind of like part of a equilateral triangle, oh, that's always half the side. The short leg is half the hypotenuse. And then the long leg, if you take the short leg and multiply by square root of 3, you get the long leg. Let's just try one. So if I say this is 10, that would mean, and this is 30, 60, 90, same problem, same kind of thing. So going backwards, you would say, okay, the short leg is the key to everything, right? We have to go through that. So it can't just go straight from the hypotenuse to the long leg. You have to go, okay, short leg would be half that. That's 5, because that's multiplied by 2 to get that. So you divide by 2. And then multiply by square root of 3 to get the other side. So that's kind of working backwards kind of thing. Let's try a really tough one here. So if we had, say the 60, it's hard to say, but that's the short leg there. Okay, so let's say this is 10. The long leg is 10. To go backwards, to the short leg, you would go 10 divided by root 3, which again, you have to simplify. So that would be 10 root 3 over 3. The hypotenuse is twice that, so that would be 20 root 3 over 3. So that'd be kind of a really tough problem there, but I think it's much tougher than that. If they give you the long leg first, it's hard to convert backwards, kind of a thing usually, unless it happens to have a square root of 3 in there, and then it works out a little nicer. That's your lesson. Hopefully that was a review. I do want to at least mention this one. If you want to try this one, you can solve for p, but don't stop there. It's a halfway answer. If you solve for p, and then you're going to plug it back in there to get 3p plus 2. I think the correct answer is actually it's actually 5. So you can try that if you want and see how that works.